Hello everyone, this is day 36 of my journey to improve my communication skills. Today I studied about compiler design and machine learning. So in compiler design basically what I studied, first one is SDD, which is a syntax director definition, and which is basically used to check whether the given syntax within the index follows the grammar rules or not, whether it is whether the expression is right or not. And it is of two types. First one is synthesized STD, and second one is inherited STD. So what is synthesized? When we apply the approach from the child to parent, then it's synthesized, and then we apply from the parent to child, then it's known as inherited. And after that, I studied about DAG, which is basically a direct acyclic graph, and used for the optimization of the expressions. Whatever the anomalies, whatever the repetition of the expression in the given grammars, it will remove that and form the best parse tree which doesn't contain any kind of the repetition of any kind of expression. If in case an expression is repeated, it will reuse it as a previous expression, not solve it again and again. That is basically properties of the tag. And after that, I studied about tag, which is the address node, how we represent the any grammar into a tag. Tag basically we can use maximum three variables in this study quadruples, triples, and then optimize triple. So quadruples we will use three operators, three operand, one operator, final result. In case of triples we will use uh, three operator, but in case of result we will store it as a value only. And in triple we will use as a pointer to store the values. After that I studied about type checking. Type checking is basically used whether the given grammar follows the is it compatible or whether given variables are compatible or not. Compatible means, for example, if we take some variable as an integer and another variable as a float, if we try to add both them, whether they are compatible or not, this will check by the type checking. So type checking there are two types. First one is static type checking. Another one is dynamic type checking. Static, if we check during the compile time, then it is known as the static type checking. But if we check it during the runtime, then it is known as a dynamic. Then it is known as a dynamic type checking. So convert uh, how we convert the any kind of variable to another variable or another data types. First one is an implicit conversion. In implicit conversions, which is also known as automatic conversions, we don't need to do anything. It automatically converts from one data type to another data types. But in explicit conversions, there is a need to manually change from the any kind of data type to another data types, but manually. So that's all which I studied in compiler design. Now what I studied in machine learning that I want to tell. So in machine learning I studied the module through. Module 3 I studied backpropagation, support vector machine, different types of the support vector machine, linear and nonlinear, and that's all. So what is basically backpropagation algorithm? So backpropagation algorithms is a supervised learning algorithms that is used to check whether the given that is used to minimize the errors with the help to train it will help to train the models, train the multi-neural network model, and minimize the error with the help of the decent parser a decent parser generator. So basically every step it reduces the error value, and in the final we will get the target output is equal to the expected output. There is some numericals on it. And after that I studied about SVM, which is support vector machines. It is also a supervised learning models that is used to for the classification of the data with the help of separators, which is known as hyperplane, optimized hyperplane. How it will find hyperplanes? There are some methods. So it is of the two types, linear and nonlinear. Linear is basically when we can separate the data with the help of single line, and non-linear is when we require curved format to separate the data, that is known as non-linear. And linear we can easily separate. Non-linear is some difficulty. Structure is simple. Structure is complex, and there is also a multi-level classification of SVM. We can use one to one versus one and one versus the other tricks to classify the data. And after that, I started about decision tree and random forest. What is the difference between decision tree and random forest? So decision tree is basically a tree that generate the multiple branches of the tree to find the output on the basis of a given condition. But in case of random forest is an ensemble learning. Ensemble means collecting a lot of things. It is an ensemble learning algorithms which generates the multiple decision trees, and final output will be generated on the majority voting. That is basically a random forest. So random forest is performs better than the decision tree because the result is from the multiple trees, not a single tree. So predicted value has a more accuracy in case of random forest. And the applications of these are image recognitions, uh, algorithm trained prediction, medicine diagnosis, and a lot of things like that. So after that, I studied about what is a Q-learning algorithm. So Q-learning is basically a reinforcement learning algorithm. Reinforcement means learning from the rewards. Reinforcement learning that that helps to take the best decisions from learning from the rewards, and rewards we will get from the environment. So Q-learning we will have a normal formula through which we can solve the values and the output to match with the expected requirement. And after the Q-learning moves, I learned about stacking. Stacking basically is also an ensemble learning models in which we collect multiple models and use that act as a multiple models act as a meta model. Meta model, all the models are set make a set of one model that is known as meta model, and the output will be generated from the meta model. So this work I am going to explain. So the different models. First, we will give the input to the different models. All the models will generate some output. Suppose we will use SVM support vector machine, decision tree, and then random forest. I will generate the output, and the output collectively goes input to the meta model, which is a collection of the models, and the final output generated by the meta model. And what is the benefit of this? The final output which we are going to get is more accurate, more precise, and have less accuracy, and it will reduce the insecurities of each model. Whatever the bugs in a model, it will reduce that. So yeah, that's all what I studied, and this is the video 36. So thank you for watching.